Stop believing the postcard version of railroad history. The glorious black and white photos of smiling engineers and perfect steam plumes are a lie constructed by corporate PR departments. They want you to believe the transition from steam to diesel was a gentle passing of the torch, a logical step in industrial evolution. It wasn't. It was a violent, expensive, and humiliating collapse that they actively tried to scrub from the archives. The truth is that before the railroads gave up on steam, they panicked. They built monstrosities that defied physics, wasted millions, and embarrassed the most powerful executives in America. These weren't just bad designs. They were mechanical nightmares that tore up tracks, suffocated crews, and failed so spectacularly that the blueprints were practically burned. You haven't heard of these engines because they were never meant to be remembered. They were meant to disappear. You're watching rust and thunder, excavating the forgotten iron. If you want to dig deeper into these buried engineering secrets with us, subscribing ensures you're on the manifest for every investigation. To understand why these machines were erased, you have to understand the sheer arrogance of the early 20th century. This was the era of superpower, a time when American railroads believed there was no limit to how big a steam locomotive could get. The logic was intoxicatingly simple. If a locomotive with 8 driving wheels is strong, one with 12 is stronger. And if 12 is good, why not 24? It was an arms race not against foreign powers, but against the limitations of steel and thermodynamics. The railroads were drunk on tonnage. They wanted to move mountains with a single crew, cutting labor costs by building engines that could pull trains 3 miles long. But in their greed for power, they forgot that a locomotive is a living system, a delicate balance of fire, water, and pressure. When you push that balance too far, the machine doesn't just break down. It rebels. The first casualty of this hubris is a machine the Erie Railroad would prefer you viewed as a quirky experiment rather than a catastrophic failure. Enter the triplex. In 1914, the Baldwin Locomotive Works rolled out a Leviathan that looked less like a train and more like a mobile industrial plant. Named the Matt H. Shea. This engine was a 2-8-8-8-2. If you know your wheel arrangements, those numbers should terrify you. It had 3 separate sets of driving wheels, one under the front, one under the middle, and one under the tender. It weighed nearly 900,000 pounds. It was, on paper, the most powerful steam locomotive ever built, capable of exerting over 160,000 pounds of tractive effort. It was designed to conquer the Susquehanna Hill, a brutal grade that required multiple engines to shove freight to the summit. The Erie Railroad boasted that the Matt H. Shea would do the work of 3 standard engines. They were right, but only for about 10 minutes. The failure of the triplex was not in its muscle, but in its lungs. The designers had made a fatal miscalculation that seems obvious in hindsight but was blinded by ambition at the time. They added cylinders and wheels to generate power, but they didn't, and physically couldn't, increase the size of the firebox and boiler enough to feed them. The moment the engineer opened the throttle, the triplex would lurch forward with earth-shattering torque. It could snap couplers and drag mile-long trains as if they were toys. But as those 6 massive cylinders gulped down steam, the boiler pressure plummeted. The fireman, shoveling coal into the inferno, was fighting a losing battle against the laws of physics. The harder the engine worked, the faster it died. It was an asthmatic giant. Halfway up the hill, the Matt H. Shea would often find itself stalled, gasping for breath, its massive frame nothing more than a roadblock of cold steel. The embarrassment was immediate. The Erie Railroad had hyped this engine as the future of heavy haulage. Instead, they had a machine that was too slow for the main line and too short-winded for the hills. Couldn't generate steam fast enough to sustain anything beyond a walking pace. The exhaust from the rear set of cylinders was routed out the back of the tender to try and create a draft, but the distance was too great. The steam cooled and condensed, raining hot, dirty water down on the crew and obscuring the view. It was a miserable, wet, choking experience to operate. But the railroad couldn't just scrap it, not yet. They had invested a fortune. So, they quietly relegated the most powerful engine in the world to pusher service, hiding it on the back of trains where its failures would be less public. It spent its short life shoving from the rear, a humiliating demotion for a machine built to lead. By 1929, long before the steam era truly ended, The triplexes were cut up for scrap. No preservation, no museum piece. The Erie Railroad wanted the evidence gone. But the triplex was just the beginning of the desperation. As the 1930s approached, the threat wasn't just gravity. It was the internal combustion engine. Diesel was coming. It was efficient, clean, and didn't require hours to fire up. The steam traditionalists, deeply entrenched in the railroad hierarchy, panicked. They needed a miracle. They needed steam to evolve into something futuristic, something that could match the sleek efficiency of diesel. This desperation birthed the steam turbine experiments, a chapter of railroad history that is perhaps the most heavily redacted of all. The concept was sound in theory. Replace the violent, reciprocating pistons of a standard steam engine with the smooth, high-speed spin of a turbine, similar to what powers a battleship. It promised massive power at high speeds with none of the pounding that destroyed tracks. The Chesapeake and Ohio Railway, a company that made its fortune hauling coal and had a vested interest in keeping steam alive, went all in. They commissioned the M1 class. These weren't just trains. They were land ships. Clad in orange and silver streamlining, they looked like rockets. They carried their coal in the front, the boiler in the middle, and the water in the back. They were electrically driven, using a steam turbine to spin a generator that powered electric traction motors. It was the complexity of a power plant compressed into a rolling chassis. When the M1s debuted in 1947, the press releases were ecstatic. They were supposed to pull the chassis, a luxury streamliner that would redefine travel between Washington and Cincinnati. But the reality inside the cab was a nightmare of leaking pipes, electrical shorts, and mechanical chaos. The coal dust from the front hopper blew back into the traction motors, shorting them out. The turbine was finicky, sensitive to vibrations and dirt, two things that define a railroad environment. The M1s spent more time in the shop than on the rails. They were maintenance hogs that required a team of specialists just to keep running. The chassis streamliner never even entered service. The cars were sold off, and the M1s, the supposed saviors of steam, were quietly parked. The C&O didn't just retire them, they erased them. In a move that speaks volumes about the corporate shame involved, the M1s were scrapped in 1950, just 2 years after being built. Think about that. Millions of dollars, thousands of man-hours, and cutting-edge technology, all torched and melted down in 24 months. They didn't save a whistle. They didn't save a number plate. The railroad wanted to pretend the M1 never existed. It was a financial black hole that the shareholders were never meant to fully understand. The silence surrounding the M1 wasn't an accident. It was a strategy. If you admit the technology failed, you admit you bet the company's future on a fantasy. This pattern of build, fail, destroy, deny became the standard operating procedure for the final years of steam. The railroads were fighting a war against obsolescence, and like any losing army, they started deploying wonder weapons that were dangerous to their own crews and disastrous for their bottom lines. They built high-pressure boilers that were essentially bombs waiting to detonate. They experimented with water tube fireboxes that leaked incessantly. Every time a new superengine failed, it was dragged to the back of the yard and cut apart before the trade magazines could ask too many questions. But there is one story of erasure that stands above the rest, a tale of a locomotive that worked too well, only to be sabotaged by the very industry it was built to save. To find it, we have to look at a machine that didn't fail because of physics, but because of politics. This is where the narrative shifts from incompetence to conspiracy. The railroads weren't just hiding their failures. They were starting to hide their successes if those successes threatened the new diesel order. The transition was no longer about engineering. It was about contracts, oil, and the deliberate killing of the coal-burning engine. Let's burn the polite version of history right now. The idea that the steam locomotive died of natural causes is a lie. It was murdered, and the weapon wasn't efficiency. It was corporate leverage. You have been told for decades that the diesel engine arrived as a savior, a sleek technological marvel that simply outclassed the dinosaur that was steam. That is a fabricated narrative designed to cover up one of the greatest industrial strong-arm robberies of the 20th century. The reality is that by the late 1940s, steam technology was on the verge of a massive evolutionary leap. a leap that was deliberately strangled in the crib because it threatened the new oil-dependent economy that Wall Street was building. To understand the magnitude of this erasure, we have to look at the machines that were actually running on the rails, not the marketing brochures distributed by General Motors. In the early 1950s, the Norfolk and Western Railway, a company built on the back of coal, decided to run a definitive test. They weren't interested in sentimentality. They were interested in profit. They took their Y6B class steam locomotive, a compound articulated beast capable of ripping houses off their foundations, and pitted it directly against the modern diesel equivalents of the day. The results were not just surprising. They were catastrophic for the diesel narrative. The data showed that for heavy-haul tonnage in mountainous terrain, the modern steam engine was cheaper to operate, cheaper to maintain, and significantly more powerful than the diesel units trying to replace it. To match the tractive effort of a single Y6B, the railroad had to lash together 3 or 4 diesel units, tripling the complexity and the failure points. The steam engine was winning on the spreadsheet, but this presented a terrifying problem for the industry. If the numbers proved steam was superior, the billions of dollars being poured into diesel infrastructure would be exposed as a waste. So the narrative had to be adjusted. The comparison tests were quietly shelved. The focus was shifted from cost per ton-mile to availability, a metric rigged to favor diesel because it ignored the fact that steam engines were being serviced in roundhouses that hadn't been updated since 1920. This is where the strategy of deferred maintenance became the silent assassin of the steam era. Railroad executives, under immense pressure from board members who were often sitting on the boards of oil companies and locomotive manufacturers, began a systematic campaign of neglect. It wasn't that the steam engines broke down. It was that they were no longer allowed to be fixed. Imagine a machine designed to tolerances of 1/1000th of an inch, subjected to the violence of the rails, and then denied oil, denied tightened bolts, and denied the skilled labor required to keep it singing. When these neglected engines inevitably began to limp, the failures were photographed, documented, and paraded as evidence of steam's obsolescence. It was a self-fulfilling prophecy engineered from the top down. They stopped cleaning the flues. They stopped filtering the water. They let the boilers scale up and the fireboxes rot. And when the efficiency dropped, they pointed at the gauge and said, "See, the technology is failing." But the sabotage went deeper than just neglect. It extended to the very infrastructure of the continent. A steam locomotive is a thirsty beast. It relies on a network of water towers and coaling stations spaced at specific intervals along the line. To kill the engine, you didn't need to scrap the metal, you just had to cut the supply line. In a coordinated move across major lines, infrastructure crews were ordered to dismantle water towers and coaling towers often before the diesel replacements had even fully arrived. This created a logistical nightmare where steam crews were forced to endure impossible delays, waiting for auxiliary water cars, or limping to distant stations. These delays were then recorded as steam failures. The schedule fell apart not because the pistons stopped firing, but because the railroad had deliberately removed the life support system. It was a war of attrition, and the steam engine, for all its power, could not run without water. This brings us to the most tragic chapter of this industrial burial: the destruction of the prototypes. The railroads didn't just scrap the old engines. They aggressively erased the super steam projects that were attempting to modernize the technology. Consider the fate of the Chesapeake and Ohio's M1 steam turbine. This wasn't a chugging Victorian relic. It was a futuristic, streamlined power plant on wheels, generating electricity through a steam turbine to drive traction motors. It was designed to run on coal but operate with the smoothness of an electric grid. The M1 was a complex machine, certainly. It had teething issues, as any revolutionary prototype does. But instead of refining the engineering, instead of fixing the dust intake issues or the traction motor wiring, the project was abruptly canceled. The 3 units built were not preserved for a museum. They were not studied. They were cut up with a haste that suggests panic. They wanted the evidence gone. If you appreciate us digging through these rusted archives to bring these destroyed blueprints back to light, taking a second to subscribe ensures you don't miss the next investigation into industrial history. The haste to scrap the M1 wasn't just about clearing yard space. It was about clearing the psychological space. If a steam turbine proved viable, It would undermine the exclusive dominance of the internal combustion engine. The M1, along with the Pennsylvania Railroad's S2 turbine, represented a third way, a path where coal continued to power the nation's transit without the smoke and inefficiency of the past. That path had to be closed. The manufacturers of diesel locomotives, specifically the Electromotive division of General Motors, utilized a brutal tactic known as reciprocity to ensure this closure. The argument was simple and devastating. GM was one of the largest freight shippers in the world. If a railroad wanted GM's freight business, the lucrative contracts for hauling cars and parts, they needed to buy GM's locomotives. A railroad sticking to steam, or worse, developing their own modern steam engines like the Norfolk and Western, risked being blacklisted from millions of dollars in freight revenue. The engineering departments of the railroads were overruled by the traffic departments. The chief mechanical officers, men who had spent their lives perfecting the physics of steam, were told to sit down and shut up. The decision had been made in the boardrooms. The coal-burning engine was a political liability. By the mid-1950s, the atmosphere in the roundhouses had turned from innovation to funeral preparations. The skilled boilermakers, the masters of fire and water, saw the writing on the wall. The morale collapse accelerated the mechanical collapse. Why maintain a machine that the boss says is garbage? The pride of the craft was broken. However, the railroads were about to discover that in their rush to erase the past, they had made a grave miscalculation about the future. They had traded a fuel source that was abundant and cheap, domestic coal, for a fuel source that was subject to geopolitical volatility. They had locked themselves into a single propulsion technology, abandoning the diversity that had kept them resilient. And just as the last steam fires were being dropped, the cracks in the diesel promise began to show. The early diesels were not the maintenance-free miracles they were promised to be. They were fragile. Their electrical systems were prone to burnout. Their prime movers cracked under the stress of heavy drag service. But by then, the water towers were gone. The coaling docks were demolished. The tooling to build steam parts had been melted down. There was no going back. The railroads had burned the bridge behind them, forcing themselves to march forward into a diesel future that was far more expensive and far less reliable than anyone had admitted. They had silenced the steam whistle, but they couldn't silence the economics. And as the decades rolled on, a few rogue engineers began to look at the discarded blueprints of the late steam era and ask a dangerous question. What if we were right the first time? What if the failure wasn't in the machine, but in the men who ran the companies? This question would eventually lead to one of the most secretive and bizarre projects of the late 20th century, a project that terrified the diesel monopoly more than anything else, the ACE 3000. The ACE 3000 was not a nostalgia trip. It was a declaration of war against the established order. You have been told for decades that the transition to diesel was an inevitable march of technological progress, a survival of the fittest where the superior machine won. That is a convenient fabrication. The truth is that by the late 1970s, the diesel-electric locomotive was already hitting a performance ceiling, and the fuel crisis was bleeding the railroads dry. The ACE 3000 proved that the failure wasn't in the physics of steam. It was in the imagination of the boardrooms. This machine was designed to do the impossible: burn coal with the cleanliness of a power plant, generate tractive effort that would snap a diesel coupler, and do it all without a single fireman shoveling coal. It was the ultimate rebuttal to the diesel monopoly, and that is exactly why it had to be destroyed. To understand the magnitude of this erased history, you have to look at the sheer audacity of the engineering. This wasn't the romantic steam engine of the 1940s with exposed driving wheels and a trailing plume of black smoke. The ACE 3000 was a predator in disguise. It was designed to look exactly like a diesel unit, a cowl body structure that hid the reciprocating machinery inside. It was fully automated, utilizing computer-controlled combustion systems that adjusted the draft and fuel feed millisecond by millisecond. It solved the two biggest arguments the railroads used to kill steam: maintenance costs and thermal efficiency. By using a condensing system, it recycled its own water, eliminating the need for the water towers the railroads had so eagerly demolished. It was a closed-loop system of raw power, capable of burning cheap domestic coal while the price of diesel oil skyrocketed due to geopolitical instability. The prototype designs suggested a machine that could outpull 2 standard diesel units at a fraction of the operating cost. The math was undeniable. The engineering was sound. The coal industry was ready to back it with millions of dollars. But the ACE 3000 ran headfirst into the one barrier that torque and horsepower cannot overcome: corporate ego. The major railroads had spent 30 years convincing their shareholders, their workforce, and the public that steam was archaic. They had scrapped thousands of viable locomotives, torn down coaling towers, and retooled their entire maintenance infrastructure for internal combustion. To admit that a modern steam locomotive was actually superior would have been an admission of a colossal, multi-billion-dollar strategic error. It would have meant admitting that they had burned the furniture to heat the house. If you appreciate uncovering these lost chapters of industrial history, helping this channel grow ensures we can keep digging into the archives that companies would prefer stayed buried. The resistance was subtle but suffocating. While engineers looked at the blueprints with awe, executives looked at them with fear. General Motors and General Electric, the titans who now held a duopoly on motive power, had zero interest in retooling their assembly lines for a technology they claimed to have vanquished. They controlled the supply chain, the financing, and the narrative. The ACE 3000 was starved of oxygen, not because it wouldn't work, but because it threatened to work too well. When oil prices stabilized in the mid-1980s, the immediate financial pressure on the railroads eased just enough for them to justify killing the project. The second steam age was canceled before the first wheel could turn in revenue service. The blueprints were shelved, the teams disbanded, and the industry went back to sleep, content with the status quo of incremental diesel improvements. But the failure goes deeper than just one canceled project. The erasure of the ACE 3000 represents the moment the railroad industry stopped being an engine of innovation and became a manager of decline. By rejecting the radical efficiency of modern steam, they locked themselves into a single fuel source and a single mechanical philosophy. We are seeing the consequences of that failure today. Modern railroads are struggling with emission tiers, fuel costs, and tractive limitations that the engineers of the ACE project had solved on paper 40 years ago. We traded the potential of thermal mastery for the convenience of standardized mediocrity. There were other victims of this purge as well, other locomotives that were quietly shuffled off to the scrapyard because they didn't fit the mold. The coal turbine projects, the electric diesel hybrids of the late century, all of them were subjected to the same rigorous suppression. The narrative had to remain pure: diesel is king. Anything that contradicted that was treated not as an experiment, but as a heresy. The graveyards of American railroading are not just filled with obsolete iron. They are filled with the corpses of better ideas. When you stand next to a modern locomotive today, listening to the idle of its V16 diesel engine, you are listening to the sound of a monopoly that won by default. You are looking at a machine that exists because it was the safe choice, not the best one. The ghost of the ACE 3000 haunts every mile of track where a heavy freight train stalls on a grade, or where a railroad surcharges customers for rising fuel costs. It is the phantom limb of the American transportation network, a capability we severed willingly. The locomotive failure was never about the machines failing the men. The steam locomotives of the late era, the turbines, and the aborted advanced concepts like the ACE were faithful servants. They were powerful, adaptable, and rugged. The failure was a failure of courage. It was the decision to prioritize the quarterly report over the 50-year horizon. The railroads were never allowed to admit that they had thrown away the key to their own future. They built a world where the only option was diesel, and then acted surprised when they became slaves to the oil market. In the end, the rust that covers the few surviving steam giants in museums is not just oxidation. It is the physical manifestation of a forgotten truth. These machines were not replaced by something better. They were replaced by something easier. The industry chose the path of least resistance, and in doing so, they erased a future where the rails were ruled by monsters of efficiency that breathed fire and water. The silence of the steam whistle is not the silence of peace. It is the silence of a censored history. The ACE 3000 and its kin remain the greatest locomotives that never were, standing as a testament to the fact that sometimes the wrong side wins the war. The tracks are empty of their thunder, but the blueprints remain, waiting for a generation brave enough to ask the question again. What if we were wrong?